A single displacement reaction is one where a reactive element will displace or knock out another element from a compound. And we have two examples here. Generic forms A plus B C forms AC plus B, or D plus BC forms BD plus C. The key to remember is that a metal displaces a metal. So metal A will displace metal B. Or a nonmetal displaces a nonmetal. Nonmetal D will displace nonmetal C. Not all displacement reactions will occur, and so we need to have a way of predicting. For example, if I try to add silver to copper 2 sulfate, I would get no reaction. So what we have is what we call an activity series. What this does is it lists our elements according to their chemical reactivity, with the most reactive at the top of the list and the least reactive near the bottom. And a more reactive metal can displace a less reactive metal. So a metal higher up can displace a metal lower down. Here's our series. So if we look at this list, calcium, because it's above iron, would be able to displace. So calcium would displace iron from a compound. But silver would not displace tin. Well, within our activity series, we also have a couple of other breaks that we are interested in. So our first one goes from down to sodium, and we saw this in our lab. These are elements that can react with cold water to displace a hydrogen and produce hydrogen gas. Our second category goes down to about chromium. These are our elements that would react with hot water, and they would still displace a hydrogen to produce hydrogen gas. Our third category are elements that would displace hydrogen from an acid, and these are any elements that are located above hydrogen activity series. Yes, hydrogen is not a metal, but by placing hydrogen in the list, it allows us to see where this break occurs. And then the third category that we have are elements that could react with oxygen in the atmosphere. And so they would react with atmospheric oxygen. And so one of the key things we can see here, for example, is that our precious metals of silver and gold are below this breakpoint. And so that's why silver and gold don't tarnish. We looked at the reaction of lithium with aluminum. We could come to our activity series, and we can look for lithium. We can look for aluminum, and we can see that lithium is above aluminum. So therefore, a displacement reaction would occur because lithium can displace aluminum. So then we can displace it. And then we have to make sure to always go back and balance our equation. Okay. If we were to look at our second example now, we're going to look at nickel and calcium. We can see that nickel is below calcium, so nickel would not be able to displace calcium. And so in this case, we'd have no reaction. And in our final reaction, our potassium with water, we don't see water on our metal activity series, but we remember that we have our breaks of hot water, cold water, hot water, and so we remember that potassium can displace the hydrogen from water. Sometimes it helps to think of water as HOH, and this way we can see our potassium displacing the hydrogen easier. And then we're left with a potassium hydroxide, so it displaces this hydrogen, leaving the OH behind, and the two hydrogen atoms then combine to form hydrogen gas. And then we just have to make sure we balance. We can also have a single displacement reaction involving elemental nonmetals, and they would displace the nonmetal. And so here we have an example. And just like we had an activity series for our metals, we also have one for our nonmetals. And likewise, a nonmetal at the top of the series can displace a nonmetal near the bottom.